Hello guys, so in this video I'm going to go over how to apply integration by parts. And basically the idea of integration by parts is that you apply it whenever you have two x variables, not one but two. And then you also make sure to attempt u substitution, and if u substitution does not work, then you apply integration by parts. And if you don't know how to use u substitution, I have a video on that as well. So without further ado, I'm going to go over how to do integration by parts. So the first thing is we have a function 3x times cosine x times dx. So the first thing we're going to go ahead and do is we're just going to simply just pull the 3 out. We pull out all the constants, so our function looks like this: x times cosine x dx. And well, now we solely focus on what's inside the integral sign, and we do not worry about the constant until the very end of the problem. So now I want y'all to note this formula right here. The integral of u times dv equals u times v minus v times du. So for this particular problem, the next step would be to identify u and dv. So that's what we're going to go ahead and do. And so we set it up like this. So we have a u and we have a dv, and these come from this function right here. But the key step is, how do we select which one's which? Because at the end of the day, we select a u and a dv, and then we, based off of these selections, we get our v by integrating dv, and we get our u by taking the derivative of u, and we plug them into this formula that we see right here to solve integration by parts. But here's this neat trick that is called LIATE. So basically, LIATE is an acronym that we use in integration by parts for priority ranking. So basically the idea is that we go from here down in selecting u. So basically the idea is our u will be whichever one of these functions comes first. So for example, x is considered an algebraic function, cosine x is considered a trig function. So since in this priority ranking algebra comes before trig, our x will be our u, which means the remainder of the function will be our dv. So in this case, cosine x dx. And now from this information, we obtain du and v by integrating cosine of x, which is simply sine of x, and then du, which is simply 1 times dx. So now that we have our variables, the next step we do would be, we're going to go ahead and just simply plug them in. So we plug into formula. So our formula is up here, and our u and our dv was on our left hand side, which we identified to be x times cosine of x, which was our original function. Now we plug in, as we see, u times v minus the integral of v times du. So we're going to go ahead and do that. We're going to go ahead and plug in these variables. So u times v, x times sine of x minus the integral of v times du. So our v is sine of x times du. Our du is just simply dx. So now the next step is to solve the remaining integral. So notice we have a sine of x right here. Inside the integral sign, sine of x times dx. All we simply do now moving forward is just get rid of the integral sign and then apply the plus c. So x times sine of x minus the integral of sine of x is negative cosine of x. And all of this plus c. And now, don't forget that we had a 3 that we had originally pulled down. So we include it in our final answer. Just make sure it's outside the parentheses. So our final answer is going to be 3 parentheses x times sine of x, 2 minus signs form a plus sign, plus cosine of x plus c. And that's our final answer. So in retrospect, for integration by parts, the first step we do is we recognize its integration by parts by recognizing that we have 2 x variables. So 2x variables. And then u substitution does not work. So I'm just going to write down here. U sub doesn't work. So once it meets these two conditions, then we go ahead and apply integration by parts by selecting a u and a dv. And we do this by using our Lie-8 system. So we use Lie-8 as a priority ranking to determine what our u is going to be. So depending on which of the two functions comes first, then that's how we determine what our u is. And whatever is left will be our dv, including the d of x. So make sure you don't forget that. Now, what if we're tied? So what if we have two functions that are both the same? Then what that means is that either u substitution works, or you can probably simplify them. So if you have two logs, you can simplify them using log properties. If you have two algebraic expressions, or two trig functions, or two exponentials, then you can definitely simplify them. So that's the case if you have two that are equal in ranking, which is almost never going to happen. So anyways, after you identify u and dv, take the derivative of du to get dx, integrate dv to get v, and then you plug them into the formula, plug them into this formula, u times v minus the integral of v times du. After you do that, the next step would be to just solve until you have no integrals left. And then that's your final answer. Thank you for watching. I hope this was helpful. Hello guys, so in this example, we're going to go ahead and cover integration by parts. And the idea is basically to apply integration by parts when u sub doesn't work, and whenever you have two x variables. So in this case, u substitution will not cancel out the other variable, so u substitution will not work. Also, we have two x variables. We have e to the x and we have x squared. So in this case, we can apply integration by parts. So the first thing we're going to do is very simple. All we're going to simply do is just pull a constant out. So this 5, we're going to pull it out of the integral sign because it doesn't help us solving this integral. So let's pull it out. So 5 integral e to the x times x squared times dx. So now the next step that we're going to have to do is we're going to have to identify u and dv. So u, du, because all these are variables in the formula for integration by parts. V dv. But we need to select a u. So we can actually do this by simply applying liate. So I'm going to do it off to the side over here. Liate is a priority ranking, and liate is an acronym for log, inverse trig, algebra, trig, and exponential. So in decreasing order, we start from liate as the highest priority ranking. So for example, if we have a log, that's most cases our log is going to be our u, and in exponential, most cases it's going to be our dv. So we go down this list and we identify each function. So we know x squared is an algebraic function, and e to the x is an exponential function. So as we look at liate, we see that algebra on the priority ranking comes before exponential. So in this case, our u is going to be our x squared because algebra comes before exponent. So u is equal to x squared, which means our dv is the remaining function. So don't worry about the 5 that we pulled out. Our dv is e to the x times dx. Now we integrate this to get our v, which is e to the x, and we take the derivative of x squared to get our du, which is equal to 2x. So now we have identified our 4 variables that we're going to use for integration by parts. And the next step would be to plug into formula. So that's exactly what we're going to do. So our formula is u times v minus the integral of v times du is equal to the integral of u times dv. We have our u and our dv, which is our function. So we just need to plug in respectively v, u, and du. So our u is x squared, our v is e to the x, and I put parentheses around them so that way you can visualize what's being plugged in where, minus the integral of v. Our v is e to the x, and our du is 2x. So the next step is going to be actually to apply integration by parts again, because we have 2x variables where u substitution doesn't work, and we have 2x variables. So we're actually going to go ahead and we're going to apply integration by parts one more time for this specific integral. And keep in mind that this is already solved, so don't worry about these, but we do need to apply integration by parts again, which means that we applied literally the same process. So right here, I'm going to write down what we have so far. So we have x squared times e to the x minus the integral of e to the x times 2x. So looking at this, the first thing we do is we pull the 2 out, times dx, sorry. So we pull the 2 out, so integral, and I'm going to not write these, but they're implied that they're going down. So minus 2 integral sign e to the x times dx. So now we have to do the same process. So the next step would be to solve integral. To solve integral, we apply integration by parts again. And I'm going to label it as IBP, but it's understood to be integration by parts. So we're going to go ahead and apply integration by parts again, which means that we have to select a u, a dv, and then from those we get our v and our du. So in this case, a rule of thumb that I will say is do not switch your u and dv from previous integral, from previous step. So do not switch your u and your dv. That's a common mistake that a lot of beginners make, but don't do it because it does make your problem solving a lot harder. And if you apply lyate, then it'll prevent it from happening, but it does still happen a lot. So just don't switch it up as a rule of thumb. Do not switch up your u and your dv. So applying lyate and knowing our u is going to be x, which means the remaining function is the remainder of the function is going to be our dv. So e to the x times dx. So we integrate this respectively, take the derivative of this respectively, and now we apply integration by parts one more time. So we're going to go ahead and do that. So integration by parts, u times v minus the integral of v times du is equal to the integral of u times dv. v u. Okay, perfect. So now it's just a matter of plug and chug. So we don't forget what we did up here. So we're going to bring those down here. So x squared times e to the x. And now this is where we start plugging these in. So keep in mind this was inside a negative integral sign. So minus 2, because we have a 2 right here. And now we plug in u, which is x, v, which is e to the x, minus the integral of v, which is e to the x, times du, which is dx. And yeah, we still have to solve this integral one more time, but we're going to go ahead and just do it right down here. So e to the x minus the integral of e to the x is just e to the x. And keep in mind that this is all inside a 2. And right here from our first integration by parts, we got this function right here. So don't forget to multiply it back in. And yeah, this is a lot of steps. This is more just repetition of steps and not forgetting to bring down the variables. And all this, we do not forget that we had a constant of 5 right here. We had a constant 5 that we're going to go ahead and we're going to just basically, we're going to pull it all the way down here. So multiply everything by our constant 5. So 5 parentheses, or brackets rather, x squared times e to the x minus 2 parentheses e to the x minus e to the x. And you could factor if you want to. I'm not going to. Make sure your brackets are consistent, or your parentheses are consistent. And at the end, don't forget to add a c. So don't forget about your constant. Just pull it out because it makes the integrating a lot easier, but don't forget to multiply it at the end, at the very end. And so in this case, we had a repeating integration by parts. And so it's just basically applying the same process, just doing it multiple times. But yeah, do not switch up your u and your dv from previous step because it will offset your integration by parts. It'll cancel it out almost, and it'll make the problem longer and harder. So don't do that. Apply lyate as your priority ranking to select u, and always start with the log first and just go down there. If it helps, do this step right here where you identify what each one of your functions are. So identify your x squared was algebraic, your e to the x was exponential, or whatever function. It could be a cosine or a trig or a log or an inverse trig. identify which one of these they would classify as, and then it'll make it easier for ranking them. And then after that, you go ahead and just plug them in to the integration by parts formula, solve out every integral. Sometimes your integral requires you to do integration by parts again, so you apply it again until you have no integrals left. And that's how you do integration by parts. I hope that example was helpful. Please let me know if you have any comments, questions, etc. But thank you for watching.